Hello guys, welcome back once again. Now we shall look into a problem which is on high swing current mirror. So which is a high swing current mirror with reference current 120 microampere and power supply so on so and the overdrive voltage MOSFETs are given. So COX and we shall start solving. So in high swing current mirror we shall not draw the complete circuit, we shall draw the last stage of the high swing current mirror. So this is this is the cascode MOSFET, cascode MOS. This is the mirror MOS. So the bias voltage is coming from the other part of the circuit. As of now, we shall not worry about what circuitry is present left side. So now we shall start solving. So in the sub question A, they asked about the minimum headroom voltage. So the minimum headroom voltage is given by so I will call it as M2 and this as M1. So headroom voltage of high swing MOSFET is given by VOV of cascode MOS and VOV of the mirror MOS. So VOV and VO2 and VO1 are given in the question. So VO2 is the cascode MOS and having headroom voltage of 100 millivolts, and VO1, which is the mirror MOS, having a value of 150 millivolts. So when we add up this, we'll get around 0.25 volts. So this is the minimum headroom voltage of the high swing current mirror, which is an advantage compared to cascode current mirror, where there was a threshold voltage which is getting added up. So that was a drawback. So only we moved from cascode current mirror to high swing current mirror. Now the second sub question, aspect ratios of the transistors. So they are asking W by L, what is the W by L2 and W by L of 1. So now we shall start finding. So we can see that lambda is not equal to 0, so there is a channel length modulation effect. So definitely these two transistors will be biased in saturation. So I shall write the drain current equation. ID1 half mu n Cox W by L of 1 VOV1, which is nothing but VGS minus VT 1 plus lambda VDS1, because channel and modulation effect is present. So we need to obtain W by L from this equation. So that would be ID into 2. So ID given is the reference current given is 120 microampere. So I'll be substituting the same here, 120 micro into 2, and mu n Cox. So mu n Cox value is 100 micro, and overdrive voltage of ID1, that is M1. So overdrive voltage of M1, which is mirror MOS. So the mirror MOS has a overdrive voltage of 0.15 volts, and overdrive voltage of cascode MOS, which is VO2, as the value of 0.1 volt. So I'll be substituting here. So 0.15 VOV square, okay, just minus VT square, I missed the square term here. So into 1 plus lambda is given in the question as 0.1, and VDS. So VDS is the minimum voltage which is maintained so that it is in saturation. So VGS minus VT is nothing but VOV itself. So the minimum voltage maintained is VDS min, so that is VOV1. So the overdrive voltage is nothing but the VDS min, so I'll be substituting that 1.15. So when I evaluate this would be around 0.15 So W by L is around 107. So this is the aspect ratio which is asked in the question. Similarly, we'll do it for the other MOSFET, aspect ratio of M2, which is W by L of 2, which is a cascode MOS. So we shall obtain the same by using the same equation. ID2 is 1 half un Cox W over L of 2 VGS minus VT whole square, that is VO2 square into 1 plus lambda VDS2. Since channel length modulation effect is present, so 1 plus lambda VDS terms comes into the picture. So W over L of 2 is ID2 into 2. ID2 and ID1 both are same, because the same current will be flowing, that same 120 microamp current will be flowing through ID1 and ID2. So ID, which is 120 micro into 2 divided by mu and Cox value is 100 micro, and VOV2, which is 0.1 square, and 1 plus lambda IDS is 1 plus lambda value is 0.1, and VDS2 is the minimum voltage required to keep the MOSFET is in the saturation, which is VGS2 minus VT, which is nothing but the overdrive voltage itself. So VDS2 would be 0.1 volts itself. So when evaluated, W over L of 2 would come around 240. So these are the aspect ratios of both the MOSFET which was asked in the question. So the next question is output impedance of current source. So output impedance will be seeing from this terminal. So we see clearly a cascode structure. So there is a cascode structure which is present. So for the cascode structure, we know that when M2 is present on the top and M1 is present in the bottom, so we are interested in calculating the R out from this point. So R out would be RO2 plus RO1 plus GM2 times of RO2 times RO1. So now we shall obtain the RO2, RO1 and GM2 values. So RO2 and RO1 are both are same, which is given by 1 by lambda times of ID, because ID is same in both the MOSFETs. So RO2 would be the same too. So lambda value is given in the question and ID is 120 micro. So when we evaluate, this would come around 83.33 kilo ohms. Similarly, we have to evaluate GM2 also. GM2 is given by we shall use this equation, 2 times of ID2 divided by VOV2. So ID2 we know that it is 120 microamps again, and VO drive voltage of MOSFET 2 is 0.25 volts. So altogether it would come around 1.6 millisiemens. So now we shall substitute the same in the equation of that R out, 83.33k plus 83.33k plus 1.6 milli, 83.33k, 83.33k. So when evaluated, R out value would be 11.28 mega ohm. So this is what was asked in the question. What's the output impedance of the I swing current mirror? So that's it guys. Thank you.